Hi, this is Algebra 1, Lesson 98. We're going to talk about the distance between 2 points and the slope formula. We're starting on page 412. Hi, kitty. Get out of the way. Silly boy. You can sit there as long as you block the sunshine. In the last lesson, we used the Pythagorean Theorem to find the missing side of a right triangle. So here we have a right triangle with the legs that are 4 and 7, and if we wanted to find C, we would remember that the Pythagorean Theorem is a squared plus b squared equals c squared. So we could say 4 squared plus 7 squared equals c squared, right? 4 squared is 16. Plus 7 squared is 49 equals c squared. 16 plus 49 is 65 equals c squared. So if we take the square root of both sides, we get c equals the square root of 65. And that would be your answer. Okay? If we have 2 points, and we graph them. Let me pull out a graph paper here. So here we have 2 points. We have -3 and -2. And we have 4 and 2. Okay? Once we graph them, we can find the distance between them using the Pythagorean Theorem. All right. So, if we made a straight line between these 2 points, we could find the distance between these 2 points, which would be the length of this line, correct? And we're going to do this by dropping this line so it crosses the x-axis and bringing across this line so it crosses the y-axis. Until the lines meet, and now we have a triangle. These 2 lines meet at a 90-degree angle, so now we have a right triangle. And we can count up the distance from here, this point to this point. Well, we know this went up 2 from the 0 line, and it's down 2 more, so we have 1, 2, 3, 4. So this leg is length 4. Sorry. This leg we can count across is 1, 2, 3, 4, 5, 6, 7. Excuse me. So this leg is length 7. Okay. Now we can find the length of this line by using the Pythagorean Theorem, because this side is going to be our hypotenuse, or our C. So we can say that c squared is going to equal 4 squared plus 7 squared, and we just did that. That's the same thing we did over here. So we know that c equals the square root of 65, and at the moment you can just leave it at that form. You don't need to give me a decimal answer. Okay, so let's try another one. Find the distance between the points 3 and -4 and -5 and 2. Okay, so I've graphed the 2 points. We're going to draw a straight line between them. Okay, we're going to have this point go up and this point come across. So we form a right triangle. This line is the hypotenuse, and it's also the distance between these 2 points, right? The distance from this point to here is actually the distance between this point's x-axis, x coordinate, and this point's x coordinate, right? This is going from this x-coordinate to this x-coordinate. So the difference in the x-coordinates is going to be 3 minus minus 5. Right? Which equals 8. So this distance is 8. Okay? This leg is the difference in this point's y-coordinate and this point's y-coordinate. And we can find that by subtracting. We'll have negative 4 minus 2, which equals negative 6. Since we're talking about a distance, it's really an absolute value. We're just talking about the size of something. So this distance is 6. Even if we had left this a negative 6, in order to find this one, we're going to square things, so it would have come out as a positive anyway. But when we're talking about distance, this is just 6. It's 6 units apart. Okay. Now we can use the Pythagorean Theorem and say c squared equals, this leg is 8 squared, this leg is 6 squared, and this equals 64 plus 36, which equals 100. So c equals the square root of 100, which is 10. Okay? Your book wants you to understand how to find the distances between the 2 points graphically, so you can see how they got it, how they figure this out. So the book doesn't go on to the next step, which is giving you the distance formula, so you can figure these out without graphing the points and drawing the triangle. Because it's going to make sense to you when we do the next part, I'm going to go ahead and give you the distance formula. But you need to understand this part. You need to know where the distance formula came from. So if you have any questions about this part, email me and let me know, and I will try to go through it for you again. Okay? So as we saw, the distance between these 2 points is really the difference of the x-coordinates, right? The distance between these 2 points is the difference between the y-coordinates. So we can extrapolate and say the distance between these 2 points, okay, these 2 original points squared, so distance squared equals the difference in the x coordinates squared, right? We squared them, plus the difference in the y coordinates squared. So here's our distance formula. D squared equals the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. And as you can see, this is very similar to the Pythagorean theorem, where c squared equals a squared plus b squared, where the a is the difference in the x's and the b is the difference in the y's. Okay? If we look on page 414 in your book, it has a graph which shows our points. Okay? So here are the 2 points that they found. Here's point 1, and the point coordinates are x1 and y1. And here's point 2, where the coordinates are x2 and y2. Okay? Here's this leg, and this leg is the difference in their y coordinates. So you can call this leg y2 minus y1. It's the change in y. You can call this leg, which is the difference in their x coordinates, x2 minus x1, or the change in x. Okay? So instead of graphing all of these, you need to understand where the information came from. You need to be able to do this by graphing. But once you do that, as long as you understand that, we can go straight to finding the differences distances between the points without graphing the points. Okay, so let's try it over here. Find the distance between the points -2, -2, and 4 and 3. Okay? It doesn't matter which point is point 1 and which point is point 2 as long as you keep them in that order. So if we use this one as point 1, if we use this one as point 1 and this one as point 2, then we're going to say the distance squared equals x2 minus x1 squared plus quantity y2 minus y1 squared. Okay? It doesn't matter which point you call point 2, but you need to have both their x and y coordinates as the from point 2. Okay? So we're going to call this one point 1 and we're going to call this one point 2. So we're going to say d squared, the distance between the points squared, equals, here's point 2, so we're going to say 4 minus 2 quantity squared plus, now we're going to go back to point 2 and say 3 minus 2 squared. Okay? So d squared equals 6 squared plus 3 minus 2, so that's 5 squared, which equals 36 plus 25, which equals 61. D squared equals 61. We're going to take the square root of both sides and say d equals the square root of 61. Okay? The answer does not have to be pretty to be correct. So that's the distance between the 2 points. Okay, we're going to do some more of those, but let's move on for a little bit. We're going to talk about the slope formula, which we have talked about before. And you remember the slope is the difference in y over the difference in x, right? If we have a line, we have graphed a line, and we find 2 points on the line, any 2 convenient points, we can find the slope of that line by taking point 1 and point 2, finding the difference in y and the difference in x, right? So the difference in y is going to be y2 minus y1 over x2 minus x1. Remember, we've done this before. So just as when we were working through the distance between 2 points, we can graph 2 points on a line and make a triangle, just the way we did it with the distance in 2 squares, or we can just use the slope formula. Okay? So, let's try this example. Find the distance between -3 and 4 and 5 and -2, and then find the slope of the line that passes through them. So first we're going to find the distance between the 2 lines, and then we're going to find the slope. Okay, so we're going to start by finding the distance. The distance formula is d squared equals x2 minus x1 squared plus y2 minus y1 squared, right? Once again, it doesn't matter which point we call point 1. Let's start by calling this one point 1 and this one point 2. So, d squared equals the difference in the x's, so we have 5 minus 3 squared plus -2 minus 4 squared, right? Okay, so d squared equals That's going to be 8 squared, which is 64, plus, this is negative 6 squared, which is 36. 64 plus 36 is 100. We take the square root of both sides, and d equals 10. Okay? Now we're going to find the slope. The slope is the difference in y2 minus y1, over the difference in x. So x2 minus x1. Okay? So we'll use the same points as 1 and 2. So we're going to start with the y's this time and say negative 2, negative 4 over 5 minus minus 3. You remember when we're doing distance, we're going to come out with a positive because we're squaring everything. So even though this turned into a negative 6, we squared it so it's a positive 36. Slopes can be negative, so we need to be very careful with our signs to make sure we come out with the correct slope. Okay, so we have negative 2 minus 4, which equals negative 6, over positive 8, and we can simplify that to negative 3/4. Okay? If we had decided that this was going to be 0.1 and this were going to be 0.2, we would have come out with the same answer. So let's try it again and make sure that that's true. So, A, the distance squared equals the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Okay, now this is 0.1 and this is 0.2. So distance squared equals, we have negative 3 minus 5 squared plus 4 minus minus 2 squared, which equals negative 8 squared plus 6 squared, which equals negative 8 squared is 64. 6 squared is 36, which equals 100. So d squared equals 100. D equals the square root of 100, which equals 10. Okay, so those two were the same. Now let's do the slope using this is 0.1 and this is 0.2. So the slope is going to equal the difference in y, so y2 minus y1, over the difference in x, x2 minus x1. Once again, slopes can be negative, so we need to watch our signs. Okay, so this is 0.2 now. So our y's are going to be 4 minus minus 2 over negative 3 minus 5, which equals 6 over negative 8, which equals negative 3/4. Okay, so it doesn't matter which point is 0.1 and which one is 0.2, as long as x1 and y1 come from 0.1 and y2 and x2 come from 0.2. Okay? And that is it for that lesson. Okay, try the practice problems. Make sure you understand them graphically, but then you can do them with the distance formula and the slope formula. Let me know if you have any questions, and try your homework. Thank you.